Hey guys, so today we're going to go over background for Kirchhoff's laws. Um, the first of Kirchhoff's laws is Kirchhoff's current law, which is KCL. So all that states is that the current that flows into a node in a circuit is equal to the current that leaves the node in the circuit. This is similar to the idea before that the current is the same throughout connections in series. You can't have a buildup of electrons in a point because the electrons all repel each other. So you cannot have a buildup of electrons inside of the node at a junction. So all the current that flows in, all the electrons that flow into the junction have to also flow out of the junction. So just for this example, we have 2 amps flowing downward, 3 amps flowing to the right, 1 amp flowing out to the right, and asks how many amps of current is leaving the junction from that bottom from the bottom branch, and we can find that using Kirchhoff's current law. So the current entering is equal to the current leaving the node. And the current entering the node is those 3 amps plus the 2 amps, and the current leaving is the 1 amp plus the I1, and we can solve this for I1 equals 4 amps. So that's pretty straightforward. It doesn't get a lot harder than that. It's usually straightforward like that. Then Kirchhoff's voltage law states that if you travel through a loop in a circuit, then the total change in voltage is 0. Initially, this might be kind of confusing. You might say, why? But after thinking about it, it's actually quite straightforward. It's like if you're hiking and you're on a mountain and you start at one point on the bottom of the mountain. So here's your mountain, you start at one point, and then you hike all around the mountain, whatever, and you end at the same point. And then you say the starting height is equal to your ending height. And this, of course, if you start at the same point, the starting height is going to be the same as the ending height. And it's the same here. If you start at some point in a circuit, and then if you start at some point in a circuit, and then you travel around the circuit, no matter where you go, if you start and end at the same point, the electric potential of that point will be the same. So your starting electric potential will be equal to your ending electric potential, and the total change in voltage when you travel through the circuit is 0. So here we have a practice problem. It asks, it wants to find the voltage drop along the resistor at the bottom. So we have a battery that's plus 5 volts right there, and then we have a voltage drop of 2 volts right there, and then another battery right there, and asks what is the voltage across this battery, and has these labeled A, B, C, D. So voltage from A to B, as you travel from A to B. So our loop is going to be A to B to C to D. So we have the voltage change from A to B plus the change in voltage from B to C plus the change in voltage from C to D plus the change in voltage from D to A is equal to 0. And again, this should make sense because if you start at A and then you travel around the circuit and then you end at A, the total change in voltage should be 0 since your start is the same as the end point. Traveling from A to B, we go from the negative side to the positive side of the battery, so we increase by 5 volts. Then traveling from B to C, we are going from the positive end to the negative end of the resistor. So what that means is the current is flowing in this direction. So the change in voltage when going from B to C is minus 2 volts. And then when going from C to D, we also have a minus 2 because we're going from the positive end to the negative end. So we're losing 2 volts there. And then plus, and we don't know our delta, our change in voltage from D to A. And this is all equal to 0. So solving this equation, we get that the change in voltage when traveling from point D to point A is negative 1 volts. What that means is point D is 1 volt higher than point A. So this is a little bit trickier than Kirchhoff's current law, but after practicing it a little bit, it's not that difficult. You just have to traverse the circuit and be careful every time you pass over a circuit element to make sure you get the positive sign and the negative sign correct. So here we're going to do an example problem. Find the values of current I1, I2, and I3. So I'll draw this circuit real quick. So the question asks us to find I1, I2, and I3. So I'll write KCL for this top node here. So that gives us I1 plus I2. So we have I1 flowing into the node, I2 flowing into this node, and I3 flowing out. So current in equals current out. So you have I1 plus I2 equals I3. Then I'll write Kirchhoff's voltage law for this loop here. So I increase 5 volts when traveling this battery because I'm going from the negative side to the positive side. And then I will drop voltage when traveling through here because the current is in this direction. So I will drop I1 times 15 ohms, right? If we use Ohm's law, the voltage across this resistor is I1 times 15 ohms, and we're going to drop that. The current flows from high to low, so this must be the high and this must be the low, and we're going to drop that voltage right there. And then down here, this current is I3, and we're again going from the high to the low voltage, so we're going to drop another 10 times I3 volts, and the total change is 0. Now we do the same loop for the other side, and we get so we start by increasing 10 volts as we pass over the battery, and then here the current is I2, and here's the positive and the negative because the current flows from high to low. So we'll drop 30 times I1 there, or I2, sorry. And then down at this other resistor, we will again drop 10 I3. And these are our 3 equations with 3 unknowns. And now we just have to solve this system of equations. To solve them, I will do 2 times the second one and add that to the third. So you get 20 volts minus 30 I1 minus 30 I2 minus 30 I3 equals 0. And then 20 minus 30 I1 plus I2 minus 30 I3 equals 0. And then we know I1 plus I2 equals I3, so I'll plug that in here. So we have 20 minus 60 I3 equals 0, and then solving this gives us I3 equals 1 over 3 amps. And I'll leave it as a fraction for now. Then we can plug that into these other 2 equations. So we have, this one is now 5 minus 15I1 minus 10 over 3 equals 0. And so 15I1 equals 10, 3, 15, so 5 over 3 I amps, and then dividing by 15 on both sides gives us I1 equals 1 over 9 amps. Then for then using the I1 equals I3 again, or I1 plus I2 equals I3, then we have I2 equals 2 over 9 amps, and this leaves us with I1 equals 1.111 milliamps, I2 equals 222.222 milliamps, I3 equals 333.333 milliamps. And that's how you solve this. So it was a pain in the butt solving the systems of equations, and also going through Kirchhoff's voltage law can be a little bit tricky, but with practice and being careful, it is not too difficult. Hopefully that helps and makes sense.